Hi, good morning, everybody. So we have 7 students here. Then kita ada another 5 minutes before 9. So we wait until 9, yeah?
Good morning, Cha.
Okay, good morning, Mei Hui. Okay, so good morning, everybody. So today we are going to continue with our lesson, and we have 21 students here. We, the two classes are supposed to have 43. Okay, never mind, maybe they'll join us a bit late. Okay, so uh, for the homework that I gave you, only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Only 12 of you has passed up the homework. Okay, what about the others? I haven't received any from you all. Okay, you answer the question in your exercise book, and then you take the picture and send WhatsApp to me. Okay, send the picture to me through WhatsApp. Okay, so far only Ivy, Nadia, Sarah, Yoshini, Kalpana, Tejiasin, Sutashini, Jessamine from 5E has passed up their homework. And as for 5M, only Izati, Weiwen, Tashvini, and Meihui. Okay, so I'm still waiting for the rest. And you are supposed to submit your homework yesterday. Okay, yesterday was the deadline. Okay, however, for those who haven't sent me WhatsApp on your exercise, please do so. Okay, if possible by today, because I'm going to use your exercise as your PBD. Okay, most of the teachers take your exercise, the exercise that they give you, as your PBD. Okay, since we are not face to face. Okay, we are only doing class online. So this is one method for us to do PBD. So hopefully for those who haven't submit their homework, please do so, yeah? Sorry. Okay. So today we are going to continue with the force resolution. Okay, the homework that I gave you is on force resolution, where you need to resolve force for the lady who are mopping the floor, and the other one is for the boy who are going down the slide. Okay, so that is the homework that I gave you, which is from page 15 on your textbook, activity 1.5. Okay, so for number 2 and number 3, you are to determine the magnitude of forces. And as for the discussion, there is no correct or wrong answer, because this is discussion. You are giving your opinion. So I want to know what do you think about the purpose of the resolving of force, and also the suitability of resolving force into two components that are not perpendicular. Okay, so there are no wrong or right answer for that. That is discussion. I only want to know what is your idea on that. Okay, so if you cannot answer the discussion, then it's no problem, because it is opinion. Then there is no wrong or right answer. Okay, so today we are still going to discuss on resolution of force. Okay, hold on. Okay, so this one is also from your textbook. I'm using most of my bahan from the textbook. Okay, so this one is from page 15 also. Example 1, solving problem involving resultant force and resolution of force. Okay, so here, as you can see, there is a box on the table. Okay, and from the diagram, there are 4 forces acting on the box. As you can see here, you have the weight of the box, which is downward direction. And then we have the normal force, upward force, and we have the friction, and also we have a pulling force. And the pulling force is at a 30-degree angle from the table. Okay, so if you look at A, you are to calculate the magnitude of horizontal component and vertical component of pull T. Okay, for those who just entered, who just joined our class, the example that I'm showing is from page 15. Okay, so without looking at the solution, can Jessamine, can you please give us the magnitude for horizontal component for T? Okay, if possible, don't look at the solution. Yes, Jessamine? The vertical, the horizontal component for T. So what is the horizontal component? Jessamine. Jessamine. Can all of you hear me clearly? Boleh dengar tak?
Yes.
Okay. So Jessamine, if you have a problem with your speaker, you can write your answer in the chat. So as for the component, horizontal component for T, okay, what is the horizontal component for T? If you cannot see clearly on the screen, you can refer to your textbook, page 15, example 1. But if possible, don't look at the solution yet. Yes, Jessamine? Still no response? Can someone help Jessamine? Archana. Archana, what is the horizontal component for T?
Actually, 1 minute, I'm doing.
Sorry?
Actually, 1 minute, I'm doing.
Okay.
Teacher, is it 31.1769?
How do you get 31.16?
36 cos 30 degree. I resolve the full force.
Okay. 36. And then
Cos 30.
36. And then
Cos
lagi
30.
cos 30. Okay. Okay. So the horizontal component is this one. Usually, if you refer to books, textbooks or reference book, they will give the symbol of fx for the horizontal component. If you want to put fx also can. If you don't want to put fx also can. Boleh sahaja. Okay. So we take the value for t. The value for t is given in the box, which is 36. Okay, so this is the value for t. And then as you can see, this is the angle for the component, which is 30, and the angle is exactly next to the component. Di sebelah saja. Therefore, we use cos. So you get 36 cos 30 berapa tadi? Siapa tadi yang jawab?
31.18.
Okay, 31.18 Newton. Okay, so what about the vertical component, Fy?
36 sine 30 degree.
Okay, so 36, and since y is further compared to fx as for the angle, so it is sine 30. And you will get berapa?
18 Newton.
13. 13, is it?
18. 18.
18 Newton. Okay. As for the homework that I gave you, some of you do the calculation. However, you did not write your answer with the unit. When you do calculation, you need to write your answer with the correct unit. Okay, ada a few yang hantar dah buat calculation for the components, but then you forgot to write the unit. Okay, so next time when you do any calculation, if there is a unit for that calculation, please write the unit. Okay, sebab takut nanti kalau tak ada unit in exams, tak dapat jawab, tak dapat markah. Okay, okay. So this is for A. Okay, we solve and then we calculate the magnitude for the horizontal component and the vertical component. And B, determine the magnitude and direction of the resulting force acting on the block. Okay, so as for the block, just now we have calculated the component. Okay, we have calculated the horizontal component. Tadi 30, berapa tadi? 31.18. And also we have calculated the vertical component 18. Okay. So vertically and horizontally, if you look at the diagram, for vertical forces, there are two forces upward, which is the 18 Newton R and also W. And we have horizontal forces, two forces horizontally, which is the 31.18 and the horizontal component for T. Okay. So you are to determine the magnitude and direction of resultant force acting on the block. So we should calculate for vertical and horizontal forces. Okay. So if you look at this is the solution from the textbook. Okay. So the resultant horizontally is 31.18, which is the horizontal component, and then minus the friction. Okay, so since friction is opposite direction of the Tx, we must put negative sign. Okay, so we get the horizontal component as 11.18 Newton. Whereas for the vertical component, we have component 40 upward, and then we have normal reaction, which is given in the table, and we have the weight. So for the forces that are the same, they have the same sign, positive, positive, and for the opposite direction, we should have opposite sign, which is negative. So bila kita combine, kita dapati vertically the resultant force is 0. So only one resultant force, which is horizontal. Okay, so since our answer is positive and friction, the symbol is negative, therefore the direction of the box is following the direction of the force T, horizontal lah. Okay, so after we calculate the resultant force, by using F equals to ma, we can calculate the acceleration of the box. Okay, so this is from example 1, page 15, and the solution is on page 16. Okay, so that one is when the box is placed horizontally. Okay, but the force is at an angle. Okay, now we have a box which is placed on an inclined plane. Okay, so kalau inclined plane, okay. For the first example, dia bagi box tu betul-betul dekat horizontal surface, and the force is acted on an angle. Okay, so now let's say we take the box and we place it on an inclined plane. Okay, kita ambil satu plane ataupun satu apa yang troli punya landasan tu, and then kita sengitkan. Okay, kita letaklah dekat sini, let's say one block, and let's say the angle here is 30. Okay, and let's say we take a box and we place it on the plane, on the inclined plane lah. Okay, so my question is, what are the forces acting on the box? Forces apa yang act on the box? Kalpana. Kalpana, can you please share with the class what are the forces acting on the box? And let's say the box is not smooth.
Weight.
Okay, weight. Which direction is the weight?
Downwards.
Okay, down. And then what else?
Normal force.
Normal force. Which direction is normal force?
Upwards.
Upward compared to what? Compared to the table or compared to the inclined plane?
Inclined plane.
Okay, so it is perpendicular to the inclined plane. And then what else? Do we have any other forces? Let's say the plane is not smooth.
Friction.
Okay, we have friction. So what do you think is the direction of the friction?
Opposite the box.
Okay, opposite the box. Opposite the box. Macam mana tu?
It's to the left.
Okay, it's to the left and parallel to the plane. Okay, so let's say this is friction. This is normal force. Okay, and this is the weight. Okay, so what do you think will happen to the box if the friction is very small? Let's say 0.5 Newton, very small. There is friction, but the friction is very small. So what do you think will happen to the box? Kavya. Kavya? If I put the box have friction but very small. So what do you think will happen to the box? Kavya? Yes, Kavya? What do you think will happen to the box? Let's say there is no friction now. We place the box on the plane, on the inclined plane, and let's say we can eliminate the friction. So what do you think will happen to the box?
The box will move down.
Okay, the box will move down along the plane. So it will move this direction. Okay, so let's say the weight of the box is 20 Newton and the friction is 2 Newton. Okay, and I want you to calculate the acceleration of the box. Okay, we have the weight, which is downward perpendicular to the table, and we have friction that is parallel to the inclined plane, and the box will move downward along the inclined plane. So my question is, what is the acceleration of the box? Okay, and we have a normal force which is perpendicular to the box. Okay, so kita nak JC. JC, can you please tell me what is the acceleration? But before you give the value for acceleration, can you please give me what is the force that is parallel to the plane? Let me say ada dua force kan? One is the friction, the other one, let's say F, friction Fr, and F is the force downward parallel to the plane. And before you can tell me the acceleration, please give me what is F. Berapa F? The value of F berapa? Di JC. Yes, JC? Oh, can someone help JC? The value of F.
Teacher, is it we need to resolve the force of the weight?
Okay, so which one do we need to resolve? Do we need to resolve FR, R, or W?
W.
Okay, we need to resolve W. So W is not perpendicular to the inclined plane. W make an angle with the inclined plane. So berapa angle dia?
30 degree.
30 degree. Yang ini ke 30 degree? Is it 30 degree here?
So isn't it 60 degrees?
Okay,
60
is it
as
60? Why is it 60?
because the angle is one is 90 degrees from the direction is the downward one is 90 degrees and then it's 30 degrees, so 180 minus 90 minus 30.
Okay, so kalau kita tengok balik, this is 90 degree, okay, and this is 30, so this is 60, betul? And the weight should be resolved into two components. One is perpendicular to the plane, the other one is parallel to the plane. So this should be 90 degree, betul? So since this one is 60, so here is 30. Okay, so kita tak ambil yang 30 lah, kita ambil yang 60. This one is 60, so this is 60 degree. Okay, so F is equals to, so what is the value of F?
Teacher,
Yes?
I don't understand the 60 degree.
Okay, so kita lukis semula. Baik, dah penuh sangat kan? This is 30 degree and this is the box. Okay, so the weight of the box is downward. Okay, downward meaning it should make 90 degree with the table. Okay, so yang horizontal is the table, yang sengit tu is the inclined plane. Okay, so this is 90 degree, this is 30, so what is the angle here? Berapa angle kat situ? X ni, berapa?
60.
Okay, so it should be 60. 60. Because this is a 90 degree triangle. And if I draw the component for weight, which is parallel to the inclined plane, so angle di sini juga adalah 60. Nampak? Because this one is parallel to this one. Nampak dia parallel?
Yes, teacher.
Yeah. And this is F. And F is a component of W horizontally or parallel to the inclined plane. Okay, so before this, kalau kita ada, let's say we have an angle, angle macam ni kan? Kita resolve into two component. One is horizontal, tapi saya kata saya tak suka guna perkataan horizontal because when you go to this situation, the resolution of force is not horizontal. So I prefer to use one is parallel to the surface that the object is on. The other one is perpendicular to the surface where the object is on. Okay, so here you have weight. The weight is perpendicular to the table. Okay, sebab weight is always downward, 90 degree downward. However, the object is placed on an inclined plane. So the weight to the inclined plane make a 60 degree angle. And since it is 60 degree angle with the surface of the inclined plane, we can resolve this into two components. One perpendicular to the inclined plane, the other one is, one is parallel to the inclined plane, the other one is perpendicular to the inclined plane. So yang ini, kalau yang parallel tu saya bagi Fx, yang perpendicular tu saya bagi Fy. Okay, so perpendicular to the inclined plane also we have normal force. Normal force is always exerted perpendicularly to the surface. So sekarang objek tu berada pada surface yang sengit. So the normal force mesti sengit jugalah because normal force is always 90 degree to the surface. Okay, so dalam kes ini R and Fy cancelling each other. So kita tak nak ambil FR dengan FY. Yang ni kita nak fokus pada Fx. Okay, because if the surface is smooth, there will be only one force yang menyebabkan the object move, which is Fx. We cannot say W make the object move because W is downward. Object will only move following the direction of force exerted onto it. Kalau lah kita ada satu objek, let's say this water bottle, I push this way, dia akan move ikut, saya tolak lah. Saya tolak macam ni, lepas tu dia naik atas pula kan. Dia mesti ikut direction of the force exerted. And the force that is freely exerted to the object is Fx. Okay, so dalam case tadi, W kita bagi berapa value? 20. So until this stage, boleh follow tak? Yes? Any response sampai sini boleh follow tak?
Boleh.
Yes, sure.
Okay. Tadi siapa yang tanya tadi? Boleh follow tak?
Can, sure.
Okay. So, since Fx is kita boleh kata horizontal component lah sebab dia horizontal to the surface, is the main force which is W 20, and then the angle next to the component is 60, so cos 60. Let's say you don't like the number 60, nak ambil yang 30. Also can, since this is 60, this part would be 30. Because Fx and Fy is always perpendicular to each other. Fx and Fy is always 90 degree. Okay, so or 20, and since 30 tu jauh sikit daripada Fx, jadi sin 30. Both will give you the same answer. Okay, and then tadi saya kata there is friction. So friction akan always opposite direction of motion. So kalau kita letak objek tu mesti akan jatuh ke bawah. Dia tak akan automatic naik ke atas kan? So the friction must be the opposite side of the motion. So let's say tadi friction dan saya kata friction is 2 Newton. Okay. So now balik kepada soalan saya, what is the acceleration of the object? You already know horizontally or parallel to the surface, there are two forces. One is Fx, which is component of W. The other one is Fr, which is the friction. So my question is, what is the acceleration of the object? Yes.
Second to second.
Berapa?
4.
But before that, berapa 20 cos 60? 20 cos 60 berapa? Mana calculator? Can someone calculate for me? 20 cos 60.
10 Newton.
10 Newton. Okay. So, what is the acceleration of the object? And if the weight is 20, so what is the mass of the object?
2 kg.
Yes?
2 kg.
2 kg. Okay. So we know the mass of the object is 2 kg. We know there are two forces. One is the friction, the other one is the component of the weight. And now what is the acceleration of the object?
4.
4. Okay. So how do we get 4?
F over M.
Okay. F equals to MA. So F is the resultant force. Therefore, 10 Newton minus 2 Newton, you get 8. And mass is 2 Therefore, the acceleration is for m as negative 1. Okay. So, boleh? Kalau boleh, yes, Newton. Kalau boleh, kita tengok beberapa soalan. Okay. Kalau boleh, so let's look here. Formative practice 1.2. Okay, page 17. Okay, so please turn to page 17 on your textbook. Formative practice 1.2. Resolve the following force into horizontal component and vertical component. So, Kasih Alia Amani, can you please give the horizontal component and vertical component for A? Kasih Alia Amani.
Yes. Horizontal 70 cos
Horizontal
70 cos
70 cos
42.
42. So what is the value for 70 cos 42?
52.
Berapa?
52.
22.
52. 52.
52.
502.
Okay. So for the vertical component,
70 sine 42.
so this is fx. 70 sine 42. So what is the value?
46.84.
46.84 Newton. Okay. And as for B, Lian, the horizontal component, Lian, yes, Lian, Lian, the horizontal component for B, yes, Lian, 90 cos 64. Okay, 90 cos 64 for the horizontal component. So what is the value for 90 cos 64? What is the value? 39.45 Newton. Okay, what about the the vertical component? (90 sine 64). So the value for 90 sine 64 is 80.89 Newton. Okay, very good. Okay, so now we look at the second question. Figure 1.22 shows a man pushing a lawnmower with a force of 90 Newton. Resolve the pushing force into its horizontal component and vertical component. So for this question, Abi Siva.
Sure, using 90 sine 60.
So this is the which component?
Sorry, horizontal.
Horizontal component, so
Y is vertical.
vertical.
It's 90 sine 60.
Vertical component 90 sine 60.
77.94 Newton.
77.94
Yeah, 94 Newton.
Newton. And
For
then the other one is horizontal component,
component 90 cos 60.
90 cos 60. Dapat berapa?
45 Newton.
45 Newton. Okay,
Sure.
terbalik kau ni. Okay, look carefully. This is the angle 60 Newton. Ni angle-nya 60 Newton is here. So 77.94 Newton, should it be horizontal or vertical component? This one. Should it be horizontal ke should it be vertical? Horizontal is Fx, vertical is Fy.
FX should be sine and
For
FY should be the
horizontal.
cosine.
So dia terbalik kan?
Yeah.
Okay, so 77.94 should be Fx and 45 should be Fy. Okay, so let's look at B. State the function of the horizontal component and vertical component of the pushing force when the lawn mower is being pushed. So, horizontal component ni apa function dia? Now, this one is explanation. So, what do you think is the function of the horizontal component? Iridina, what do you think is the function of the horizontal component in this situation?
Is it to overcome the friction and move the object?
Okay, so horizontal component is to, yes?
Overcome friction and move the object.
Yes, okay. So the horizontal component of the force is to move the object and to overcome the friction. Okay, horizontal component, move object forward and overcome friction. Okay, so what about the vertical component? Kavitra, what about the vertical component? What is the function of the vertical component? Yes, Kavitra?
Is it to allow the lawnmower to push on the surface of the field?
Okay, to allow the lawnmower to?
To be pushed on the surface of the field.
Okay, so push the lawnmower downward so that it can easily cut the grass. Lebih kurang lah macam jawapan awak. Okay, so to push downward to cut grass. Because this is lawnmower kan. Okay, so let's say the boy don't want to push. He pulled. Instead of pushing the lawnmower, he pulled the lawnmower. What would be the difference between pushing the lawnmower and pulling the lawnmower? What will the boy feel? And what about the grass that is being cut? Nadia. Nadia Natasha. Instead of pushing, the boy pulled the lawnmower. So what do you think will be felt by the boy? And also, what do you think will happen to the grass? Yes, Nadia Natasha. Yes, Nadia? Okay, Nadia is not sure. Can someone help Nadia? Okay, Sutashini said harder to cut the grass. Okay, so the grass is not cut nicely. But what did the boy feel? Will it feel easier to move the lawnmower, or will it become harder for the boy to move the lawnmower? It is easier to move. Okay, very good, Ashley. The boy will feel that it is easier to move the lawnmower. However, the lawnmower did not do its work. Dia tak boleh cut the grass very efficiently ataupun pendek sebab dia push, dia bukan dia pull, dia bukan push. Okay. So let's look at this one. This is not in the textbook. By resolving force T into horizontal component and vertical component, determine the resultant force on the wheelbarrow. Okay, so we have a man pushing a wheelbarrow. Okay, the force of wheelbarrow, the force of pushing the wheelbarrow is 480 Newton. The weight is 760 Newton. The normal force or reaction force is 520 Newton, and the friction is 360. Okay, so what you need to do is you need to calculate the vertical component of force T. The vertical component of force T. Siapa? Yoshini. What is the vertical component of force T? Yoshini? 480 sine 30. Okay, so vertical component is this one. So it is 480, which is the cos T, and then sine 30. Okay, because the angle 30 is here, far from the component. And then horizontal component. What is the horizontal component? Okay, Archana already calculated 415.969 Newton. Okay, what about the horizontal component? Sorry. Ashley said the horizontal component is, you got 240. For which one, Ashley?
Vertical, sure.
For the
Vertical
horizontal,
one,
is
sure.
it?
Vertical, sure.
For the vertical. For 480 sine 30. Oh, so 41569 is for the horizontal for this one. 415.69. And as for the vertical, Just now tadi berapa?
240 je.
40. Okay. Salah component. Okay. So vertically, the component is 240 Newton and horizontally, the component is 415.69 Newton. Okay. So the question then asks the resultant force on the wheelbarrow. Okay, so we have one vertical forces and the other one is horizontal forces. So let us calculate resultant force vertically. So what is the resultant force for the wheelbarrow vertically? So what do you get?
Teacher,
The
is it the
resultant force,
wheel
yes.
reaction force and the vertic and the
Okay,
Fy?
how many forces are exerted onto the wheelbarrow vertically?
3.
2.
Two? Are you sure two?
3.
Okay, there are three forces. One is the reaction, one is the weight, and the other one is the horizontal component, vertical component for T. Okay, so berapa total?
3.
Okay, dapat berapa?
3 component that is acting
Okay,
vertically.
three vertical forces. So two force is upward. So let's say upward we give positive sign. So 240 plus the reaction force 550. 520, and then plus the weight. Okay, and since the weight is in opposite direction, so the weight we give negative sign 760. So dapat berapa vertically?
0 je.
Okay, you get 0 Newton. So vertically, the resultant force is 0 Newton. Okay, what about the horizontal force? How many forces horizontally?
3.
Okay, so we have two. One is horizontal component for T and the other one is the friction. So horizontally, what is the forces? Dapat berapa?
25.69.
Okay, dapat berapa? 45.
25.69.
Okay, 25.69. So you get 415.96 minus friction 390. Okay. So this is the resultant force for the wheelbarrow horizontally. So B, describe the motion of the wheelbarrow. What happened to the wheelbarrow? So will the wheelbarrow move upward, downward, to the left, to the right?
It will stay on the ground and move to the left.
Okay, so actually said move to the left, while we when also said move to the left. Okay, so the wheelbarrow will move to the left. Okay, so it's already 10. I'm going to give you homework to do, but it will be in the Google Classroom. Okay, so you are going to submit your homework in the Google Classroom. And for those who haven't submit the homework for the formative activity 1.1, 1.5, please do so because only 12 of you have submitted. Ada lagi ramai yang belum hantar. So tolong hantar And the homework I'll give in Google Classroom, and for 5E, I'm going to share the code for the Google Classroom so that you can join. Okay, sebab bila hantar dekat WhatsApp, I tak boleh mark, susah nak mark. Kalau dekat Google Classroom, after I mark, I'll send it back to you. Okay, so we stop here. And for the next class, we are going to look at equilibrium forces. Okay, so that's all. Thank you.
Thank you, teacher.
Okay.